back in geometry, you spent a lot of time talking about circles. And just to review the definition of a circle, it's a set of all points that are equidistant from a fixed point, which you remember we call the center of the circle. So the definition of a circle, you have points that are equidistant from a fixed point called the center. The distance, which we refer to as r, from the center to any point on the circle is called the radius. So what we're mainly going to do with these circles, ladies and gentlemen, is A, you have to be able to do one of two things, and that's obviously given the equation graph, or given a graph, come up with the equation. So when we're graphing our circles, if your center is at 0, 0, then the equation of your circle is simply going to be x squared plus y squared equals whatever the radius is squared. And again, that's with your center at 0, 0. Now, just like your whole transformational approach, if it's inside, it's opposite what you expect. So if your center is not at 0, 0, so suppose your center is at some point hk, then notice it's going to be x minus h to the second power plus y minus k to the second power. It's still equal to the radius squared. All right, so that's what the standard form of your equations of circles are going to look like. So for example, let's take a look at number 1. Given a graph, let's write the equation in standard form. So to write these equations, you have to know two things. You have to know the center, and you have to know the radius. If you know the center and the radius, you can write the equation of the circle. So looking at number 1, where's the center? The center is where? 0, 0. And what's the radius? 1. So that it's just simply going to be x squared plus y squared equals 1 squared, or x squared plus y squared is equal to 1. So any questions on how you can write the equation of a circle given the center at 0, 0? Let's take a look at number 2. What's the center of this circle? 0, 2. So my center is at 0, 2. And what's the radius? The radius is 2. Now, would I write x minus 0 squared? No. So you don't write x minus 0, because x minus 0 is just going to give you what? X. So when you have an x coordinate that's 0 or a y coordinate that's 0, you simply write x squared plus. And it's going to be the y minus 2 to the second power is equal to 4. And again, remember the 4 is coming from the radius squared. All right, so any questions writing the equation of the circle? Let's jump down and let's take a look at number 5. What's the center of the circle in number 5? Negative 1, 0. And then what's your radius? Your radius is 1. So now, again, with a center at negative 1, 0 and a radius of 1, it's going to be x minus negative 1. So inside my parentheses, that's going to be an x plus 1 to the second power. Plus, would I write y minus 0 squared? No, that's just going to be a y squared equal to 1. Okay. So any questions on, given the graph, how you can come up with the equation of the circles? All right. You guys go ahead and try number 6 on your own. Again, identify the center and then identify the radius. Equal to 9. Okay? So any questions on writing equations of circles? All right, like I said, it's pretty straightforward. Now let's just go the other way. Given the equation, let's come up with the graph. Just like when I wanted to write the equations, you want to identify the center and you want to identify the radius. So you always want to identify those two pieces. You're going to identify the center and identify the radius. So looking at number 7, what's the center of this circle? The center is going to be at what? 0, 0. And the radius, remember, is going to come from taking the square root of 16. And what is the square root of 16? 4. Because remember, this constant is the radius squared. So to find the actual length of the radius, you take the square root. So all you're going to do is plot the center. So that's at 0, 0. We know the radius is 4, so count 4 units to the right of the center, 4 units to the left, put a point on the outer part of the circle, 4 units up from the center, 4 units down. And again, connect those 4 points the best you can drawing a circle. So again, just connect those points. You don't need to get out compasses and draw pretty perfect circles unless you want to, but again, just draw the circle the best you can. Yeah?
Does have anything to do with the circle?
No. Okay? Now, looking at number 8, ladies and gentlemen, before you can identify the center and the radius of a circle, you've got to make sure the equations are written in standard form. Remember, in standard form, the coefficients of x and y have to be a positive 1. So looking at example number 8, before you can identify the center and radius, you have to get x squared and y squared by itself. So what are we going to have to divide everything by? 3. So you may have to do some algebra manipulation to get it in standard form. So we have x squared plus y squared is equal to 9 once we do the division. So then what's the center of this circle? The center is going to be at 0, 0, and then the radius is going to be 3. So again, I'll plot my center, go to the right of my center, 3, left 3 of the center, down 3 from the center, up 3 from the center. Okay. So any questions on number 8? Let's take a look at number 9. What's the center in number 9? The center is going to be what? -3, -2. Remember, inside opposite. And then what's the radius going to be? The radius is going to be 2. So I'm going to plot my center. And then I'm going to go to the right 2 of the center, left 2 of the center, down 2 from the center, up 2 from the center. And again, draw my circle connecting those 4 points. So any questions on given the equation of a circle, how we can graph those? Look at number 11. What's the center for number 11? The center is going to be what? -1, 0. And then what's the radius going to be? 3. So again, I'll plot -1, 0. Go to the right 3, left 3, down 3, up 3. Okay. So any questions on 11? Let's take a look at number 12. What's the center going to be in number 12? The center is going to be at what? 2, -3. Now, sometimes the world is not full of perfect numbers. Sometimes you are going to have to do approximations on the radius. So what's the radius going to be? The radius is not 7. The radius is going to be what? Square root of 7. So you're going to have to estimate this the best you can. What two whole numbers would square root of 7 be located? Well, I know square root of 4 is what? 2. What's the square root of 9? 3. So you agree with me that the square root of 7 is located somewhere between the square root of 4 and the square root of 9, correct? So square root of 7 is going to have to be some decimal somewhere between 2 and 3. So maybe like about 2.6, something like that. So you're just going to have to estimate that point the best you can. So plot my center at 2, -3. Go to the right somewhere between 2 and 3, put a point to the right of the center. Somewhere between 2 and 3, put a point to the left, down, and then up. So sometimes you will have to estimate the center the best you can. All right, so any questions on circles? Now, another shape that, again, this is going to be a new one, and that is what we call an ellipse. An ellipse is just an oval. So we know how to graph circles. So we are going to have a center. So you identify the centers of your ellipse very similar to the way that you identify centers of the circle. If you look at the numerators, you are going to see 2 fractions. The standard form of an ellipse, notice it's going to be equal to 1. So you're still adding an x squared plus y squared. These denominators are going to help us find the vertical radius and the horizontal radius, because what's creating an oval is that the distance from the outer points are not going to be equidistant like they are for the circle. So what we're going to have to do is calculate a horizontal radius and a vertical radius and find those outer points very similar to the way we graph the circles. Again, you look at the numerator. The numerator will tell you the center. So notice if your center is at 0, 0, you just see that x squared plus y squared just like you do for the circles. If the center is at hk, notice the numerators will tell you exactly where the center of the ellipse is going to be. All right, so you use the numerators to help you calculate the center. These denominators are going to be different. These denominators are not going to be the same number. That's creating the oval shape. If these denominators were the same, you would have the same horizontal and vertical radius, which means that you're going to have a circle. So what creates the ellipse is that these denominators will be different. So let's take a look at two possible orientations that we could have. So for example, let's suppose I plot x squared over 4, actually let's change this to a 9, x squared over 9 plus y squared over 4 is equal to 1. First of all, identify the center. What's the center of this ellipse going to be? The center is going to be at 0, 0. So now, to find the horizontal radius, notice it's the x-axis that goes horizontal. So what you're going to do is take the square root of the number that's underneath x. What is the square root of 9? The square root of 9 is 3. So the square root of 9 is equal to 3. That's going to be your horizontal radius. So what you're going to do, just like we did with the circles, go 3 units to the right of the center, 3 units to the left of the center. Now you're going to find your vertical radius. Remember, y is the variable that goes up and down. So now you're going to take the square root of the number that's underneath y. And what is the square root of 4? The square root of 4 is 2. So I'll go 2 units above my center, 2 units below. So now you know those 4 outer points of the ellipse. So now you can go ahead and connect those 4 points. Again, it's an oval shape. We call this a horizontal major axis because the distance from the center to the outer part is longer horizontally than it is vertically. Okay? So any questions on how I graph that ellipse? Let's suppose you have an equation that looks like this. X squared over 4 plus y squared over 9 equals 1. Looks very similar to the equation that I just graphed, except I switched the 9 and the 4. Where's the center of this ellipse? The center of this ellipse is what? 0, 0. But now to find the horizontal radius, again, whatever number's underneath x, that's the number that goes left and right to the center. So I'm going to take the square root of 4, and the square root of 4 is 2. So I'll go 2 units to the right, 2 units to the left of my center. To find that vertical radius, I'm going to take the square root of the number that's underneath y. What is the square root of 9? The square root of 9 is 3. So I'll go 3 units above the center, 3 units below the center to find those outer points on the ellipse. And then I can connect those 4 points. So you can see how switching those numbers, it changes the orientation of the ellipse. Again, we call that a vertical major axis because the distance from the center to the outer part of the ellipse is longer vertically. Okay? So now let's talk about number 1. What's the center? Let's go ahead and graph these. What's the center? 0, 0. And we agree we're not going to have a circle because we know that those two denominators are not the same and it's equal to 1. So now we want to find the horizontal distance from the center. So take the square root of the number that's underneath x squared. What's the square root of 36? The square root of 36 is 6. So I'm going to go 6 units to the right, 6 units to the left. Take the square root of the number that's underneath y. What's the square root of 9? The square root of 9 is 3. So I'll go 3 units above the center, 3 units below. And there's your ellipse. What's the center in number 2? The center is what? What's the center going to be in number 2? -2, -3. So again, -2, -3. So again, to find the horizontal distance, I'll take the square root of 4. The square root of 4 is 2. So I'll go 2 units to the right of the center, 2 units to the left. Take the square root of the number that's underneath y. And what is the square root of 9? The square root of 9 is 3. So I'll go 3 units above the center, 3 units below. And there's that center. There's that ellipse. Okay? So any questions on sketching the graphs of the ellipses? So it's very similar to the circles, except you're going to have 2 different lengths of the radius. You'll have a vertical radius and you'll have a horizontal radius to contend with. All right? You guys go ahead and try number 5 for me. And that's this ellipse you should come up with. Okay? Take a look at number 6. So what's the center in number 6? The center is going to be what? 0, 0. Now my question to you is this. There is no denominator written for x squared. What is the value of that denominator, even though it's not written? 1. So don't forget, you still have to find that horizontal radius exactly the same way. Again, the square root of 1 is just going to be 1. So I'm going to have to go 1 unit to the right and 1 unit to the left of that particular center. And then to find that vertical radius, I'm going to have to take the square root of 25, which is 5. So I'll go 5 units up from the center, 5 units down. Yep, very thin ellipse. Okay? So just don't be alarmed if you don't see that denominator. That just means that you're going to have a radius of 1. All right? Again, now let's go backwards. Let's write the equations given the graph. So you have to identify the center, the vertical, and the horizontal radius to write the equations. So looking at number 7, what's the center going to be for number 7? 0, 0. So again, I know what the numerator is going to look like. It's going to be x squared over something plus y squared over something equals 1. That's the standard form of the equations of the ellipse. Now, from the center, what is that horizontal radius going to be? The horizontal radius is a what? 1. So that would be a 1 squared. Now tell me what the vertical. What is that vertical radius going to be? 3. So that would be a 3 squared. So then x squared plus y squared over 9 is equal to 1. Okay. Yes, Claire?
Did you leave it as x squared over 1?
Yeah, if you wrote x squared over 1, I wouldn't take off.
Okay.
Let's look at number 8. What's the center going to be in number 8? -3. Is it -1? 1. I'm having trouble counting. My contact is flipping on me. It's -2, right? -2, -1. I'll be, I gotta read those lines. So now I know it's going to be then x plus 2 to the second plus y plus 1 to the second is equal to 1. So now what's the horizontal radius going to be? The horizontal radius is going to be, what's that horizontal radius? 4. So it's going to be x plus 2 squared over 4 squared. The vertical radius is going to be what? Is that 3? Over 3 squared. So it's going to be x plus 2 squared over 16 plus y plus 1 squared over 9 is equal to 1. Okay. So there's your ellipses. Any questions on ellipses? Okay, so like I said, graphing ellipses and circles hopefully isn't that, you're good with that. All right, third shape is what's called a hyperbola. Now, one thing I want to bring to your attention, the equations of a hyperbola look almost exactly the same as the ellipse. There's only one small difference. Subtraction sign. Remember, circles and ellipses have the plus. The hyperbola will have the subtraction sign. You still find the center exactly the same way as you do the ellipses and the circles. You look at the numerators and you're going to find the center. What graphing the hyperbolas are going to be different because you're going to have asymptotes. The graph is going to have two branches. So you're still going to use the denominator to count to the left and right of the center, up and down. But then we're going to draw a rectangle. You'll see what I mean by that in a minute to help us figure out where these asymptotes are going to be. So for example, let's take a look at an example of, let's say, x squared over 9 minus y squared over 16 is equal to 1. So you still want to identify the center. What's the center going to be of this hyperbola? 0, 0. So now you still want to calculate the distance horizontally from the center and vertically from the center. So again, if I take the square root of 9, that's going to give me what? 3. So I'll count 3 units to the right, 3 units to the left of my center. I still want to calculate the distance vertically from my center. So I'm going to take the square root of 16, which is 4. So count 4 up from my center, 4 units down. So far, not much has changed from graphing that with the ellipse, has it? So now what I'm going to do to help me figure out where these asymptotes are, I'm going to connect these 4 points. I'm going to draw the shape of a rectangle with a dashed line. Okay. The asymptotes for this graph are the diagonals of the rectangle. So now that you have the rectangle drawn, what you're going to do is you're going to draw a diagonal through the rectangle passing through the center. So those lines that I drew are the asymptotes. Now, what happens with a hyperbola is you could have two possible orientations. It's going to look like two parabolas. The parabolas can open left and right, or they can go up and down. It depends upon which fraction is positive. Remember, in your equation, you have a subtraction sign. Which fraction is positive? Was it the x squared or is it the y squared? X squared. Does x squared go horizontal? Does x go horizontal or does x go vertical? X goes horizontal, doesn't it? So that means that my parabolas are going to have to open left and right. So this point that I put right here on my x-axis at 3, 0, that's the vertex of the parabola. So now you can use your dashed lines that you sketched to get your graph really, really close to the asymptotes without crossing or touching them. That'll give you one branch. And then the other branch, you'll use that negative 3, 0 for the second branch. So it looks like two parabolas, one opening right and one opening left. Notice the points are on the x-axis. All right, so that's the horizontal orientation. Again, whatever fraction is positive, x goes horizontal, so I know that my hyperbolas are going to open left and right. Let's take a look at another example, the other orientation. Suppose it's going to be y squared over 9 minus x squared over 16 is equal to 1. What's the center? The center is going to be what? 0, 0. So to figure out the distance from the center, I take the square root of the denominators. Now remember, 9 is underneath y. This is your vertical. This tells you how many units up and down from the center. So the square root of 9 is 3, so I'm going to go 3 units up, 3 units down. Take the number that's underneath x, that's 16, so square root of 16 is 4, so I'm going to go 4 units to the right, 4 units to the left. So again, I'm going to sketch my rectangle. Sketch your asymptotes, which are the diagonals of the rectangle. So far it's exactly like the previous one. But now look at the original equation. Which fraction is positive? Was it the x squared fraction or was it the y squared fraction? Y squared. This is your positive one. So y goes up and down. So that means your hyperbolas are going to have to open up and down. So this point that's on the y-axis at 0, 3, that's the vertex of one of your parabolas. So again, you use the other dashed lines to open it, to get really close, but don't touch any of the dashed lines that you drew. So the way you determine which direction it's opening, it depends upon which fraction is positive. So any questions on that? So let's take a look at number 1. So let's talk about the center. Where's the center going to be for number 1? 0, 0. Which fraction's positive, by the way? Which fraction's positive? X. So that means, remember, it's going to have to open left and right because that's the direction that x goes. So again, I'm going to take the square root of 25, which is 5, count 5 units to the right of the center, 5 units to the left of the center. Take the square root of 16, which is 4, so that'll tell me how many units up and down to go. I know it's a hyperbola because of the subtraction sign. So this is where now I'm going to draw my rectangle. And again, I'll draw the diagonals. So any questions on how I sketch the rectangle or the diagonals? Like I said, x is positive. The hyperbolas have to open left or right. So that's what that hyperbola looks like. Okay, questions on that one? Let's look at number 2. Now be careful. Does everybody agree with me it's the y fraction that's positive? So be careful, though, the center. What's the center going to be? Remember, the x coordinate comes first. So what's the center of this particular hyperbola going to be? 0, -3. Guess what probably the most common error I see? -3, 0. Be careful. Remember, x goes with x, y goes with y. So I have 0, -3 as the center. Take the square root of 4, which is 2. So go 2 units above the center, 2 units below. Just like with the ellipse, by the way, what's the denominator underneath x squared? There's a what? 1. And what's the square root of 1? 1. So I'm going to go 1 unit to the left and right of the center. So you have a very thin rectangle to draw. Again, I have to draw the diagonals. The slope of these asymptotes are determined by the rectangle, the width of the rectangle. And the asymptotes, the slope of the asymptotes will determine the width of the actual graph. That's why you use the asymptotes to help you with the graph. Now the question is, y is positive. Which direction does y go? Left and right or up and down? Up and down. So then I know that this particular hyperbola is going to have to open up and down. So use the point here at 0, -1 and sketch your branches of the hyperbola. So any questions on that one? Let's take a look at number 4. You guys go ahead and try number 4 for me. What's the center here? The center is going to be what? Center is going to be 1, 2. And did we come up with this for number 4? Did we get this one for number 4? All right. Any questions on graphing the hyperbolas? All right. Last one, and then we're done. Parabolas. You guys are used to graphing parabolas that open up and down. And again, a parabola, remember, has an x squared in it and just a y. Only one of your variables is squared. We also know what the vertex of parabolas are going to look like. So if your vertex is 0, 0, there's no number added or subtracted to x or y. In vertex form, notice you'll see an x minus h to the second. Don't worry really about what that p is, but again, you'll have a coefficient outside the parentheses and then a number added or subtracted to y, if your vertex is not at 0, 0. If this 4p, if the number in front of y is positive, it opens up. If it's negative, it opens down. So you, again, get x squared by itself, and then you look at the sign in the front to determine if it's going to open up or down. If your parabola opens left or right, then instead of having x squared in the equation, it's going to be y squared. So x is not squared, y is being squared. So the orientation then is going to be the parabola could open left or right. Again, there's no number added or subtracted to x or y. Your vertex is at 0, 0. If you have a number added or subtracted to x and y, then you know your parabola is going to open, then the vertex is going to change. It'll be at hk. What's the positive direction, by the way? Think about your x-axis for a minute. Where are your positive x values? To the right or to the left of the origin? To the right. So if the number in front of x is positive, then you know it opens to the right. If it's negative, it opens to the left. So what you're familiar with is when the parabola opens up. You're familiar with that orientation. That happens when x squared is equal to y, or y equals x squared. It opens down if y is equal to negative x squared. So now, if you've got the equation where instead of having x squared, it's going to be a y squared, the parabola will open to the right. If it's a negative y squared, it's going to open to the left. To figure out the negative, remember, always isolate the squared term. Regardless of what term is being squared, get the squared term by itself and determine the orientation. So first of all, number 1, all I want you to do is tell me whether it opens up, down, left, or right, and state the vertex. So first of all, there's no number added to x, no number added to y, so what's the vertex? The vertex is just going to be at 0, 0. It's an x squared. So if it's x squared, is it going to go which directions? Up or down or left or right? It's going to go what? Up or down. Is 4/3 positive or negative? It's positive. So because it's x squared and this number is greater than 0, I know this parabola will open up. Okay? All you need to worry about with these parabolas is really know about the orientation and what the vertex is. Get y squared by itself, so divide both sides by 3. So So y squared is equal to 8x over 3. What's the vertex? There's no number added or subtracted to x or y, so what's the vertex again going to be? 0, 0. Now notice it's a y squared. So it's no longer going to open up or down, but it could open what? Left or right. So look at 8/3. Is 8/3 a positive number or a negative number? Positive. So since that's positive, which direction is it going to open? It's going to open to the what? To the right. So now let's get x squared by itself. So I'm going to divide both sides by 9, or negative 9. So x squared is equal to negative 2/9 times y. Vertex is 0, 0. It's an x squared with a negative sign. So which direction is it going to open? It's going to open where? Down. The x squared and y squared will give you whether it's going to open up or down or left or right. And then you look at the negative sign to narrow it down to the final direction. Let's take a look at number 5. What's the vertex going to be in number 5? You have a number added to x, so again, inside opposite, what's the vertex going to be? Negative 6, and the y coordinate is 5. It's an x squared. So it's either going to go up or it's going to go down. Look at the number in front of the y. Is it positive or negative? Negative, so it's going to open in which direction? Down. Look at 6. What's the vertex going to be? You have a number inside the parentheses with x, so what's the x coordinate of the vertex going to be? 9. The y coordinate will be what? 0. Now it's a y squared. So it's not going to go up or down. It could go what? Left or right. Look at this number here. You have a y squared with a negative. So will it go to the right or go to the left? Left. So any questions on how you can identify the vertex or the orientation? All right. So any questions on the parabolas? All right. So guys, your homework tonight is to do the